Welcome to the AI Research Roundup. I'm Alex. Today, May 11th, 2025, we're discussing an ICLR conference paper published just under 4 months ago. Judge Decoding, faster speculative sampling requires going beyond model alignment. This paper tackles the slowness of large language models, or LLMs, which often generate text token by token. That's their auto-regressive nature. To speed this up, speculative decoding uses a fast draft model to propose candidate tokens, which a larger target model then verifies. This paper argues current verification is too strict, so it introduces judge decoding. This new method uses a trained judge head to better decide if a draft token is good, even if it's not the target's absolute first pick, improving speed. Okay, so this first figure really illustrates the core idea. It presents a user's question and compares responses using a LLAMA 3.1 to 8B model for drafts and ALLAMA 3.1 to 405B as the target. With standard speculative decoding verification, the output is short. Only a few initial tokens are accepted, shown in green, before others are rejected in red. But with judge decoding, the response is much more complete, with significantly more green, accepted tokens. This is because the judge head uses token embeddings, rich numerical representations of words capturing their meaning, to better assess draft tokens during inference, the process of generating new text. Building on that visual, Figure 2 further quantifies this improvement. On the left, a graph shows that with standard speculative decoding, the number of accepted tokens, those are the bits of text the model agrees to use, quickly flatlines even if you give it many draft options. But with judge decoding, it accepts far more, almost linearly increasing. The right side shows bar charts. For instance, when using human-written text as a draft, judge decoding accepts about 4 times more tokens than standard methods on Wikipedia summaries. This really underscores how judge decoding better utilizes good draft suggestions. Okay, and Figure 3 really drives this point home, especially when using a very powerful model, like GPT-4o, as the drafter for the Llama 405B target. On the left, for a Python coding task, standard speculative decoding accepts just a tiny snippet of the GPT-4o draft, but with judge decoding, almost the entire correct Python function is accepted. The bar charts on the right then show this pattern across different tests, like MTBench and GSM 8K. Consistently, judge decoding accepts many more tokens, often more than 10 times as many. This clearly demonstrates how judge decoding unlocks more potential from these capable draft models. So how does this judge head learn to be so effective? Well, Figure 4 gives us a peek into its training material. It shows 2 examples from the dataset used to teach the judge head. For instance, one question asks about countries bordering France. The dataset provides both the correct list and an incorrect one, highlighting the wrong additions like Portugal and Poland. By seeing many such correct and incorrect answer pairs, the judge head learns to identify valid, contextually appropriate tokens, even if they aren't the target model's absolute top choice. Alright, so after seeing the training data, Figure 5 shows a couple of things. On the left, we see an example of conditioning the Llama 405B model on wrong outputs. Basically, feeding it an incorrect statement like, the capital of France is Berlin, and then it actually corrects itself. This ability to discern correctness is key. Then, on the right, there's a diagram illustrating the judge head itself. This approach is inspired by the LLM as a judge framework, where one AI essentially grades another. It shows how candidate tokens pass through the model's transformer blocks, those are core processing units, to produce the token embeddings that the judge then uses for its assessment. Okay, this all comes together in Table 1, which presents some really compelling numbers on performance. It compares judge decoding to standard methods and other approaches. We see the average acceptance length, shown as M* in the table. That's the number of draft tokens accepted at once, jump dramatically. For instance, with one model setup, it goes from about 6 tokens to nearly 19. And this translates to huge speedups, like up to 9.7 times faster in Hugging Face, a popular machine learning platform, and very high tokens per second in GPT-Fast, and optimized system using techniques like 8-bit quantization, which helps models run faster. So those impressive numbers really highlight the core message here. Judge Decoding offers a clever way to make these large models run much faster. It improves on speculative decoding, which is a method where a smaller, faster model proposes text that the main model then verifies. Instead of just strict matching, Judge Decoding uses a trained judge head to accept more good suggestions, boosting speed significantly. It's a really promising step for more efficient AI. That's all for this AI Research Roundup. Thanks for tuning in.